Hello and welcome to Tutorial 3. In the current tutorial we will strengthen the model that created in Tutorial 2 with reinforced jackets. Starting off, we have selected the model from Tutorial 2, and we will save the project with new name. We click Save As. And we rename the project Tutorial 3, and we click Save. We will now move on to the building modeler facility. We will demonstrate how to strengthen the building by applying reinforced jackets to the columns and beams. First, we will select the column C1, the Properties window open. And we click to see the jacket menu. We select to open the drop-down menu of jacket types. The available jacket types are the full jacket, the one-sided jacket, the two-sided jacket and the three-sided jacket. Let's select the full jacket. We can see that in the jacket menu there is also the option for the jacket material set. The Material Sets window appears where the defined material sets are summarized along with the values of concrete and steel strength for each set. Here, we may edit the default new material set that will be used in the jacket section. The values of the concrete, longitudinal, and transverse reinforcement strengths may be assigned. And we exit this window. Then we will modify the longitudinal reinforcement bars of the jacket from 2 to 4 bars at the top-bottom sides. And we may also define the transverse reinforcement of the jacket. Moving to the View Modify Geometry tab, we can go and modify the dimensions of the section by clicking the dimension label of the section drawing and inserting the desired dimension value. After having strengthened all columns, we will continue strengthening the beams of our model. So, first we click the beam B1. The Properties window opens, and we click to see the jacket menu. We select to open the drop-down menu of jacket types. The available jacket types are the full jacket, the one-sided jacket, and the three-sided jacket. Let's select the full jacket. We can go and modify the dimensions of the section by clicking the dimension label of the section drawing, and inserting the desired dimension value. Moving to the View Reinforcement tab, we may define the number and diameter of the reinforcement bars for longitudinal and transverse reinforcement. Here, we can assign the amount of reinforcement of the section by modifying the number of the longitudinal rebars. We can see that the rebars that are selected are colored in yellow for better identification. We can also define the transverse reinforcement by modifying the diameter and spacing of hoops along the beam length and the number of hoop legs at each side of the beam section. After having inserted all the jacketed columns and beams, our strengthened model is ready. We click Exit and Create 3D Model button. After having built our model, we will proceed to the next step of our analysis procedure, which is to define the code requirements for our analysis. In the first tab we can see the limit states defined by the code. Since all limit states are checked, code-based checks will be carried out for all limit states. Next, in the Seismic Action tab, we can define the characteristics and final shape of the acceleration response spectrum. In the Lateral Load Profile tab, we can choose the types of pushover analysis that we are going to carry out. The next tab is the Knowledge Level tab, where we select the second available knowledge level. Moving on to the Static Actions tab, where we can define the coefficients for the permanent and live loads. Finally, at the Checks tab, we can define the types of checks that we want to be carried out during the analysis. We will now move to the fourth analysis step, which is the Eigenvalue analysis. When we click on the Eigenvalue analysis button, the analysis window opens and we just have to click on the Run Analysis button to start running the analysis. We can click the Show Results button in order to access the full detailed analysis results. We will now move to the next analysis sub-step, which is the pushover analysis. We click the Run Analysis button to start the pushover analysis procedure. After the analysis finishes, an informative window pops up to inform us about the completed analyses. Now, we can proceed to viewing the analysis results in the SeismoBuild post-processor facility by clicking the Analysis Results button. In the post-processor facility, the analysis results can be accessed using the various available modules. We will move on the next analysis stage, which is the code-based checks stage. Here, we can access the results from different type of checks distributed in the various tabs of the module. We can view the results in table format and visualized on the 3D view model. Also, we can reveal or hide the result tables. First tab refers to the chord rotation checks results of the members. In the next tab we can view the shear forces. Next, we can view the joints shear forces, the joints horizontal hoops area, and the checks for joints vertical reinforcement area. We will now see how we are going to create the report from our analysis. So, the report window appears. Here, we are going to specify the content of our reports. The first tab concerns the general information of our model. Now in the Members tab of the report printout options, we may determine the information about the structural member checks that will be exported to the technical report. Similarly, in the Beam Column Joints tab, we can specify the information on the beam column checks that will be exported to our report. In the Foundation tab, we can specify the information about the footings if employed that will be exported to our report. Finally, in the Detailed Calculations tab, we can select to include in our report detailed calculations of the capacity checks for certain members of our structure and select OK. The report appears right after the generation is finished. We can then save our report by clicking on the Save button, and select the format type in which the report will be saved. Here we will choose to save the report in the standard PDF format, and then press OK to export our report to the PDF file. At a final stage we click the Export CAD Drawings button. In the window that opens we can specify various settings on the contents of the drawings. After we are finished, we click the Create Files button. Now, our drawings are ready. Let us view the first floor CAD drawing. The drawing contains the floor's plan view, the tables summarizing the jacketed columns, and jacketed beams reinforcement details, along with the drawings of the jacketed columns and the jacketed beams cross-sections. Congratulations! You have finished your third tutorial.